Greetings. My name is Marialaura Salinas, and welcome to another lecture from the 2020 Honors Chemistry Short Lecture Series. Did you know that chickens can give us more than just eggs? Or that chicken waste holds the highest percentages of nitrogen, phosphorus, and potassium? Well, you might be wondering why this is important. This is because the phosphorus in the chicken waste can be recovered. Today's topic is chicken manure extractions. Some key points for today's presentation will be the CNDN article, chicken manure components and uses, quick wash method, PEARS method, differences between quick wash and PEARS, outcome of PEARS, and conclusion. My presentation was inspired by the CNDN article, Extracting the Good Stuff Out of Chicken Manure. The article talked about dead zones and algal bombs in the Chesapeake Bay by Delaware and Maryland. This was caused by nutrient pollution, meaning there was too much phosphorus and nitrogen in the bay. Farmers, as fertilizers, would use chicken manure because there are big chicken farms by the peninsula area ranging about 175,000 broilers at a time in 6 houses. Chicken manure holds a high concentration of phosphorus, and farmers would overapply chicken manure, causing the dead zones. As a solution, Blaney decided to create the phosphorus extraction and recovery system, or otherwise known as PEARS. This system would extract the phosphorus from the chicken litter, creating an environmentally safe fertilizer for the farmers in the area, and it would provide other farmers phosphorus for their crops. Chicken manure components and uses. Chicken manure has a high amount of nitrogen, phosphorus, and potassium. The NPK ratio is the ratio between nitrogen, phosphorus, and potassium. These are the most important nutrients plants need. This makes it perfect for chicken manure to be used as a fertilizer, but too much can cause plants to have a high increase in phosphorus and can cause the soils to release unwanted nutrients into waterways, causing nutrient pollution. Manure can also be made into a compost. The chicken litter has enough proteins that can cause plants and crops to grow healthy. The first step for the quick wash method is to mix the poultry litter with water and hydrochloric acid. This will lower the pH to be less than 5.0. Then, the poultry litter is dewatered to prevent carbon and nitrogen oxidation and digestion. Once the poultry litter becomes a slurry, it is full of soluble phosphorus and it is sent into the second vessel. Phosphorus in the chicken litter is made into a soluble phosphorus by the acid solution creating a rapid hydrolysis. This allowed a large amount of extraction from phosphorus in the poultry litter. In the second step, the washed litter residue is subsequently separated from the liquid extract and dewatered. The liquid extract is precipitated by adding an alkaline earth base or calcium hydroxide. This increases the pH range from 9.0 to 11.0 to form alkaline earth metal-containing phosphorus compounds. Lastly, the third step, a flocculant is added into the second vessel to enhance precipitation. There is a period of time in which the precipitated phosphorus-rich solid is removed from the vessel. The supernatant liquid is reused for the next quick wash cycle. The method could be used with one vessel or two separate vessels. The first step in the PEARS system is to extract the phosphorus out of the poultry litter, but before that, the chicken litter needs to be dried for 3 days at approximately 50 degrees Celsius. Once the 3 days are over, the litter is grinded with its bedding using a food processor. This is until it is a fine texture. Then, the litter is sifted using the US mesh number 16. When this was done, the poultry litter was made into a slurry using deionized water. The slurry then goes into the reservoir, which is then bubbled with CO2 gas and hydrochloric acid for 30 minutes. Doing this lowers the pH of the slurry to 4.5. This liberates phosphorus and other elements from the solid manure particles. The solids will settle for about 30 minutes and then they pump the phosphorus-rich acid liquid to the third chamber. In the third chamber, 2 moles of sodium hydroxide were added to the liquid to increase the pH in the 7.0 to 11.0 range. The liquid is mixed for 10 seconds and the precipitate was settled for 30 minutes. Then the precipitates were washed 3 times with DI water. This was to remove soluble salts like potassium chloride or sodium chloride. After that, the precipitate was freezed at 10 to the power -3 mbar and -50 degrees Celsius. Both the quick wash and the PEARS system have almost the same process, but there are differences, starting with the extraction method. The PEARS system uses carbon dioxide gas and bubbling because they wanted to make the machine cheaper and they also wanted to use less chemicals. The quick wash system uses strong acid like hydrochloride to extract. This is because acids can convert organically bound phosphorus into a soluble phosphorus. The next difference was the precipitation chemistry. PEARS decided to use sodium hydroxide to be able to correct the pH of the substance, making it in the 7.0 to 11.0 range. The quick wash method used lime water or calcium hydroxide because they wanted to create a calcium-containing phosphorus product. Last major difference of these two major systems is the product composition. The PEARS system makes struvite while the quick wash makes hydroxyapatite. This is because the PEARS system there is enough nutrients in the poultry litter to create struvite. Chicken litter does not only have nitrogen, calcium, and potassium, but there is also magnesium, which is essential into making struvite. The quick wash method makes hydroxyapatite because there is calcium left over and the litter has the enough elements needed to make hydroxyapatite. The outcome of PEARS is quite impressive. PEARS reuses its liquid effluent, minimizing the amount of water used per cycle by 56%. 70% of the phosphorus regained by the poultry litter comes from struvite. Farmers are able to use the extracted fertilizer without endangering water sources near the agricultural lands. It will be easier for farmers to sell struvite without spending as much money as using just the poultry litter. And now for our conclusion. In conclusion, the agricultural sector is affected by chicken manure both negatively and positively. Chicken manure can be used as a fertilizer for plants, but too much of the fertilizer can cause soils to leach the nutrients into the nearest waterways. There are different processes to extract phosphorus out of poultry litter, two of which are the quick wash method and the PEARS method. The quick wash method mainly extracts phosphorus, and it was one of the first methods in which phosphorus was extracted from litter. It also uses acids for extraction, calcium hydroxide for precipitation chemistry, and produces hydroxyapatite. The PEARS method, which was inspired by the quick wash method, is a recent method created to not only extract phosphorus, but to also recover struvite and potassium struvite. The PEARS system uses carbon dioxide gas to extract, sodium hydroxide for precipitation, and struvite as its product composition. Ultimately, scientists and engineers are looking for a better way to improve these processes to be able to create a non-waste bio-friendly method of extraction or even making the litter into energy. Thank you so much for listening, and I hope you enjoyed this presentation.